Primary support for Earthlings 2.0 comes from Technica Communications, an award-winning PR firm amplifying breakthrough technologies of the future. Additional support comes from Tigo Energy, solar energy and software solutions provider focusing on commercial, industrial, and residential solar installations.
We lost our way, right? And it's not just with the electric utilities. We lost our way with Boeing, where there's been financial people leaving Boeing instead of engineers. And we lost our way on utilities. I don't understand why you would allow anyone that doesn't have an engineering degree to run a utility.
Greetings, Earthlings, and welcome back to Earthlings 2.0, the show where we imagine how we could be better versions of ourselves and build a collective future we actually want to live in. Today's show is a thought experiment with one of the brightest minds in the energy transition, Jigar Shah. I wanted to explore this concept of how we might build our energy infrastructure today if we had all of this new energy technology at our disposal from the beginning. And in my mind, Jigger's background as an engineer, founder of Sun Edison, and known for ushering in the concept of the power purchase agreement, which really unlocked solar for so many back in the 20 teens, and his former positions as director of the Loan Programs Office for the U.S. Department of Energy, CEO of the Carbon War Room, and president of Generate Capital, and so much more, that he was the mind I wanted to tap for this exploration. But before we get there, I'm your host, Lisa Ann Pinkerton. I'm the CEO of the award-winning PR firm Technica Communications and the founder of Women in Clean Tech and Sustainability. Before building those organizations, I was an environmental science, health, and tech reporter for NPR and PBS. And whether this is your first or 50th episode, thank you for joining us. We are thrilled to have you here. And please feel free to look around, watch a few other shows. If you're on YouTube or if you're listening to the podcast feed, go ahead and click through our feed. We have a lot of really interesting stories. Well, interesting to me at least. I hope you'll find them interesting too. And especially if this is your first time around, feel free to drop me a note. Let me know what you think about the show. That is one way you can help us improve the show over time. And if you like what you're hearing on Earthlings 2.0, share the show with a friend of yours next time you're talking about how somebody's in a show hole and they need some new and fresh content. Send them a link from your phone to theirs, and then they'll have it and remember to watch it. If you've done all those things, thank you so much. It's working. Thank you for your support. It really does help the show. You can join our newsletter if you'd like to get a monthly digest, and you can take our listener survey if you want to give us some direct feedback on what you think of the show. And thank you to Resource Labs for having us on the network. So this thought experiment we're going to do with Jigar Shah came about because I was contemplating the idea that our electrical grid is over 100 years old at this point, and it's legacy technology. It desperately needs to be upgraded. And would we build it the same way if we had the existing technology we have today? Instead of what we're doing now, which is trying to like bolt on new technology and keep the old technology running and all of these band-aid solutions. And if you really think about it, the whole system was just designed to transport electricity from centralized generation plants running coal and later natural gas and nuclear to homes and businesses and, entire cities. And it operates on this delicate balance of supply and demand. And when it becomes unbalanced, as you know, get brownouts and blackouts. And the spinning reserve that the grid loves to see is sometimes in conflict with how wind and solar show up on the grid, but that can be adjusted with energy storage and other grid technologies. So, with all of this, I wanted to ask Jigar, would we build the same centralized generation with poles and wires like we have today, or would it be completely different? So, if you're unfamiliar with Jigar Shah, I gave you some background at the beginning of the episode. Very impressive resume. He's also a podcaster, and he is a managing partner of a new firm that he's founded called Multiplier. And his mission there is to help a select group of high quality, sustainability focused companies to accelerate their growth and execute well timed, well managed exits. we caught up with him from his office in the Washington, D.C. area, and we just jumped right in to this thought experiment that given all the modern technology today, would we build the same type of centralized electricity grid?
Well, look, I think when you look at the technology that we have today, it's very obvious that so many people have moved to DC, right? And so when you think about batteries and everything else, like if you have a laptop, plug, that big box converts AC to DC and then feeds your laptop DC, right? So right now your house is taking in AC and then your appliances, a lot of them are using DC, right? And so LED light bulbs, lots of things can run off of DC. And so we're in this weird spot right now where I think technology has gotten us to the point where, they've chosen DC as superior to AC. We certainly didn't start out that way, but I think that's where we are now.
So based on sort of where we are now, like I kind of feel like the grid was it was designed for a different era and it had different problems that it was attempting to solve. And today we're kind of in a different place with different problems. So I feel like sometimes I think about the way the grid is set up, supply and demand, and all these wires and poles. It feels like it was a great solution for a previous problem, but now we have a different problem. And sometimes I feel like it's not the best solution.
I think that when you think about where we started, the vast majority of people were looking to, you know, get a modern lifestyle, right? The cold supply chain, right? Figuring out how to keep food from spoiling. We tried to figure out how to industrialize our country, right? And get a lot of manufacturing done and all of that stuff. And, in that time, I think that there was a feeling that having individual block level electricity, which is sort of where we started, right? In downtown New York, was less efficient than having these very large scale power generating units, using transmission, using distribution. Today, the whole point of innovation has been to make small beautiful, right? You can now achieve a lot of the reliability that, we had before in very small packages, and we've been miniaturizing infrastructure. And so, today we're in a much different place. And certainly when you think about some of the countries around the world that are not fully electrified, the solutions that we are promoting with solar and battery storage and microgrids are the preferred route to electrify those communities, because it really just doesn't make a lot of financial sense to build a large generating facility and transmission lines and distribution lines for a lot of those communities.
So based on, everything that you know from your work at the loan program and all of the work that you've done and from Sun Edison, Generate Capital, all of it, how do you think we would design the grid today if we didn't have these limitations with all the poles and wires and the big generating plants that we're using right now?
First, let me start by saying there's so many smarter people than me. And so this should become a series, I think, that you do with lots of really smart people on these things. I'm obviously happy to provide an overview, but I think there's a lot of people who have actually got an electrical engineering degree. Mine is mechanical, so we're not as well respected. But, look, I think that when you think about the way the grid is structured now, you could imagine it getting to some version of this today too, right? So if you think about starting from the very smallest unit, right? You put solar and battery storage on your home. And then you decide, well, actually, it might be cheaper to connect my house with my neighbor's house, right? And then it might actually be cheaper to connect all of the houses in my neighborhood into one microgrid, right? And then, you share and not everything is on at the same time and all that stuff, right? Which is great. And then the question becomes, the neighborhood down the road does exactly the same thing. And then you might say, you know what? Actually, it might actually be good to balance between both of us and build a distribution grid basically between the two of us, right? And so you could imagine, even if we started with individual electricity at the home level, business level, moving to the microgrid level and the neighborhood level, that you might still decide from an efficiency standpoint that it was worth stringing lines across, to connect to other microgrids. Now, the lowest cost way of doing it is above ground. And so, I don't know whether we would have done it underground. But underground is way cooler in the sense that, it survives hurricanes and floods and all sorts of other stuff.
Yeah, it's more resilient.
It's definitely more resilient. And then the question really becomes, at some point, do you actually want to build a very large central station power plant, right? And if you were to do that, then how would you get that power to all of these distribution grids, et cetera, and how would they interact with each other? I think the one thing that we did in the past, which I think would be way different today if we started again, is that right now the vibe is that the consumer of electricity can do whatever they want without any consequences, right? And the utility company is required to figure out a way to accommodate what you're doing, right? And that is a really expensive way to do things, right? And, my co-founder at Sun Edison, Brian Robertson, built a house in Baja, like near Cabo in Mexico. And he and the 9 homes or so that was on that strip didn't have a grid. And so they built their own grid. And that's how he got into solar, was he built a grid. It was solar plus battery storage, and the batteries were lead acid batteries at the time. And so he would charge, I think it was like 20 cents a kilowatt hour during the day, but then charge like 90 cents a kilowatt hour at night, right? Because, you have to get it out of the batteries, the round trip efficiency, et cetera, right? And so when you think about what that looks like and feels like, there were a lot of people who said, I don't know if I want to spend 90 cents a kilowatt hour at night. I might use a lot less electricity at night, right? And so it self-regulated people. And I think today that self-regulation doesn't really happen. And it is something we're moving towards, right? Whether it's virtual power plants or whether it's flex connect systems with folks who have large loads, but 50 to 100 hours a year, you don't have enough power in that circuit to provide power to them. And so I think that the whole social contract that we have right now is changing. And I think had we started with microgrids and individual home systems, I think it would have started that way. But today we're starting with everyone's used to be able to do whatever they want at their house, and the utility having to accommodate it. And, and so that, I think that whole thing would have been different had we started with, the home and neighborhood level.
Yeah, that's an interesting point, because a lot of us have just grown up expecting to always have power, and the utility would always provide it. And we can use it whenever we want. And I think is part of that because traditionally power was being supplied by large generation plants, and there was plenty of power to go around at certain times.
Electricity is something that people are not supposed to think a lot about, right? But it is an essential part of living a modern lifestyle, right? Whether it was refrigerators for cold beer or hot water for showers, or, there were a lot of places that didn't have natural gas. And so you had your electric stove, you had lighting, right? People were using kerosene before, right? So each and every one of these things actually led to less, human suffering, less, challenges in a person's life, and more, more ease and comfort, right? And so using more electricity was viewed as a way to get people out of poverty, get people into a modern lifestyle, figure out a way to reduce pollution, right? Because local pollution, right, like cooking with coal or cooking or heating your house with a fireplace or whatever it was pretty dangerous for people, right? And so for a long time, we were pushing people to use more and more electricity because that's how we got people out of poverty and into a more modern lifestyle. And, weirdly enough, we're doing that again today, right? Folks think they need AI. And look, from what the tools that I've seen, it does seem like at some point they're going to start charging you $1,000 a month for these modern AI tools, and they're going to triple your productivity, right? And I think the same thing is true with self-driving cars, right? And electric vehicles. Electric vehicles are clearly a far superior technology than internal combustion engines. 0 to 60 a lot faster, right? Far more responsive. But like it uses electricity instead of molecules. And then when you go to self-driving cars, you can imagine some of these cars driving 200,000 miles a year, right? So when you think right now, our cars are the worst investment you possibly make, right? Because it's just sitting there idle for 95% of the year. With Waymo, I mean, those things could drive around and pick people up and drop people off all day, every day, all night, every night, right? And so if you're driving that many miles, you're amortizing that vehicle. And, Tesla's batteries now run 750,000 miles, right? At least, right? So when you think about what electricity enables for human flourishing, sure, we can use electricity more efficiently. Emory Levins and the Rocky Mountain Institute really taught us a lot of that. But using more electricity generally refers to people living more modern lifestyle.
And you don't want to ask people to sacrifice anything. My experience is that humanity can be a little bit selfish in that respect, and it's hard to get them to sacrifice, generally speaking, for the greater good unless there's something in it for them, or unless they have a personal connection to that action. And providing people with greater abundance and greater functionality and being more sustainable as a side benefit tends to sell a lot better. We saw that with electric vehicles. And my question for you is, if we would have maybe built the same kind of grid system as we have today, even with today's technologies, do you still think we would have these massive transmission lines going across big swaths of the country? Or do you think we would have more, maybe larger grids, but they'd still be a bit more localized or regional? And would they connect over these very long distances, do you think?
Yeah, I mean, the question really becomes, what do you get for it, right? I mean, I think that we already have a balkanized system, right? You can't supply power from Nevada to New York City today, right? You have a Western grid, you have ERCOT, you've got MISO, SPP, the PJM, the Southeast, right? The Northeast, New York, California. So, you've got different grids already. There's a limited amount of transfer capacity between different grids, but it's not infinite. Like it's not, like one grid, right? And so we already have that level of balkanization. I think, if you had 50 state grids, for instance, without any transfer across different states, you would clearly be less resilient, right? So then what would happen is if you had a huge winter storm, or you had a huge hurricane, or 10-degree weather for 10 days in a row, or whatever it is, then you couldn't get the other regions who weren't experiencing that weather to help you, right? And so that's what you get out of having the large transmission grid. And then obviously today with solar and wind power, the wind is blowing somewhere all the time. And so having a transmission grid allows you to share wind power across large regions, which, may not work really for a small microgrid per se. Solar is a little bit more predictable, as in the different regions, but similar, here, I think that where you could have cloud cover in one spot and no cloud cover, 100 miles away, and then, so you're sharing there. So the whole point of transmission was to provide this level of resiliency, I think, across large distances. Initially, of course, it was just to, take a coal plant that they built in a very rural area, given the pollution, et cetera, and transport it to urban centers. But over time, I mean, I think that they did try to connect as many grids as they could to try to, allow for a lot more resiliency, right? And so you give up some resiliency if your grid size or your grid area is too small.
So, assuming we started the grid out with today's existing technologies, solar, storage, so they became like neighborhood microgrids, and they became larger grids, and they would connect to other grids, right? It seems like we would still have most of these houses would still be generating power locally and storing power locally. So then that would balance out the necessity of attempting to have people reduce their energy use at certain times because the renewable energy resource isn't there. There might be less larger generation plants within a given area, but solar and wind still variable. So would we still need some other type of what you might call baseload power, whether it's fossil fuel or geothermal or something else, fusion, nuclear, whatever the case might be? Would we still need something like that? And how many of those do you think we might need if we had all these microgrids kind of connected together regionally?
So let's start with the premise of your question. I think, um, one of the things that we do now is we have a lot of spinning reserve, right? We have natural gas peaker plants and other things that are in standby mode, waiting to be turned on or turned down, depending on what the grid needs to maintain frequency and voltage and some of those things, right? Today, we pay a lot of money for some of those peaker plants because some of them run less than 8% of the time, right? Now, you could provide that service with a battery in everyone's garage, with the same level of dexterity that you currently do a peaker plant. And that's what you see Rocky Mountain Power doing, is they're using their peaker plant less and less, and they're encouraging a bunch of residential homeowners to put in batteries in their garages that they can control at the Rocky Mountain Power level to do that. So I think we're clearly in a place right now where a lot of our centralized resources are costing us a lot of money and not providing local resiliency for homeowners, and that trade-off is positive, right? So you have this ability to shut down some of those central station facilities and actually increase resiliency at the local level cost effectively. At least that's working in Rocky Mountain Power's territory, and I think there's other people around the country that have piloted that as well. I think to your question, look, diversification is always going to be better. I think this notion that we all need to be at 90% solar power is just crazy, right? Like for me, as somebody who, self-represents as a solar guy, like I started when solar was 0.0001% of the grid, right? And today it's, like not quite 10%, I think, of the power generation in our country, but it's approaching it. And, like probably gets up to 25% of our grid, in a relatively straightforward fashion, right? Now, once you get beyond 25% of the grid, you have a huge amount of challenges, right? Because if you're just putting in naked solar across the entire grid, then, like everyone's on at the same time and you're producing too much power in the middle of the day. So now you have to pair it with batteries, okay? And people say, great, I'm going to pair it with 1 hour battery charge. Okay, that works until it doesn't work. And then you need to have 2 hours and 4 hours and 8 hours, right? And so now the question becomes, like, as that number keeps going up and you go from 8 hours to 10 hours to 12 hours to 15 hours, like, is there a balance where if you had something like a nuclear plant that was running 24/7, would that actually make everything more efficient, right? Because, there are days where you have a rainy week, right? And so there's less solar production that week. And in Germany, as usual, they've created some sort of word for everything. And so they have was it a Dunkenflauten or something, where you have 11 days of really bad wind power production, and it's in the winter, so you have less solar production. So when that happens, deciding that you're going to have, a week's worth or 2 weeks worth of battery storage is unlikely to be more cost effective than building a nuclear plant, right? So then you put that into the model and then you start iterating and you say, okay, how many nuclear plants might actually help us get to this point? Geothermal obviously is something you could sub in there. Hydro actually plays a really big role in balancing and inertia and frequency control and lots of other things. And so you could add hydro in. And so my sense is that the answer is that nothing should be above 25% of the grid, right? And that leads to diversification that you need. But if you go back to the original premise of your conversation, if what we're trying to do is microgrids, right? The vast majority of people are not going to be living right next to a place they could put hydro in, or, they're not going to have, cost-effective geothermal this week, although I think geothermal technology keeps getting better and better, so that might happen.
Yeah. I think we're going to see a lot of interesting developments in that space in the next year or so.
Totally. And then you've got nuclear plants, right? But, like a lot of those are big right now. I think there are a bunch of people trying to create 350 kilowatt to 1 megawatt nuclear plants now. And so, if those things become ubiquitous, then maybe those will end up being the anchor of a microgrid, right? But, and then when we built out our nuclear fleet, we built a whole bunch of pumped hydro storage. Many of those are 200 hours worth of storage, right? Because it's stored as water. So you've got a lot of that as well. And so this goes back to, well, why would you need to connect all the grids together? And why would you want a larger balancing area? And why would you want transmission, right? And you start to realize that for things that are not manufactured products, right? Nuclear power is not a manufactured product. Then bigger is pretty much always better, right? Like 1,000 megawatt plant is going to be more cost effective than a 300 megawatt plant. Now, eventually they might make a manufactured product and they might make these small little micro reactors I guess they're called nuclear batteries. And if you can make 100 of those a year out of a factory, maybe that ends up being much more lower cost. But we're not there yet. So, we'll sort of see where the technology takes us. And so that then reinforces, to achieve that diversification and to put in less batteries than you otherwise would have to. Having some of these other technologies, I think, is pretty important.
Now I know you're more on the tech side of things, but I do have some questions related to market rules and policy. Like one of the biggest problems we have in the renewable energy space, especially in solar, is interconnection queues and how long that takes. And sometimes I wonder, is it a line that is being artificially rationed because it's not necessarily in the best interest of a utility to bring on a competing generation technology to what it's already selling as baseload power?
So it certainly depends on the location. I'd say that, the best structure right now for interconnection is the Texas Connect and Manage, right? So in that case, there's two different studies that you do. One is to determine whether it's safe to connect your system to the grid. So Texas continues to do that. And then the second study is whether there's dedicated capacity on that line so that you can, put solar power or wind power, whatever it is, into that line whenever it's produced, right? And so in the PJM, they do both, right? And so a coal plant comes offline, that capacity frees up, and then the next, deal of the queue. Obviously, they've jumped the queue recently with a bunch of natural gas plants, but normally that's sort of how that worked, right? And then you have dedicated capacity. In Texas, you don't have dedicated capacity, so they'll just say yes to everybody who's safe to connect. And then if there's too much, well, then they'll just tell you, sorry, there's too much. You got to all shut off because we don't have enough capacity to transport it elsewhere. And then people go, oh, well, if you don't have capacity, I don't want to waste it. So I guess I'll put a battery in, right? And time shift it, right? And so my sense is the Texas approach is the best approach. The PJM approach probably leads to a lot of suboptimal utilization of the transmission lines. And then I think your example is sort of a third approach, right? Which is like Southern Company, who's vertically integrated and they own all the lines, and they are Duke or others, and they might say, sorry, we just don't like you. And, like you're not part of our integrated resource plan. And we just don't think that you're the lowest cost way for us to top down, manage our grid, a la, some sort of, Russian, planning mechanism. And so, yeah, and in that case, it could be a little more arbitrary and capricious. I don't know that it is today, but it certainly was, 15 years ago.
Well, it's interesting to watch utilities, generally speaking, treat solar and sort of EV charging differently. Because it's like the EV charging, it's like pretty clear. Oh yeah, I'm going to sell more power if I get this thing set in. Which I don't think that they see that same scenario on the solar side.
Yeah. So on the EV charging side, they view that as a load. And in general, I would say that the utilities are very comfortable with loads, right? Like, so if you're, producing, if you're using power, they sort of love it. Now they have to obviously do the study and make sure that like there's enough capacity on that.
Yeah, balance everything out.
Yeah, now they've got the flex connect approach, so they might say, well, we have enough capacity on this line, 95% of the time, but 5% of the time we don't. And so if that 5% occurs, we'll send you a signal and you have to shut down, right? So there's some of that. And so certainly utilities are more in favor of selling more power than they are managing self-generation. And putting aside any sort of profit loss sort of conversation, which there was a time when utilities viewed all this stuff as a zero-sum game, and that your, solar would have been supplied by a central generator that they already own. And so they're making less money there and getting less contribution from the solar net metering customer to the shared infrastructure costs from transmission and distribution. Today, I'd say that's less the interest. I think my sense is most utilities sort of view this as we need everything all at once, everywhere. So I think where they're concerned now is just the physics of how the grid runs, right? So the way that the grid was built is it goes from central generation to transmission and distribution, right? So the transformers are not made for power to flow up the transformer, right? And so they want to make sure that you're not actually producing so much power in that neighborhood that, at any given moment, they're going up the transformer, because that's how you break a transformer. You blow a transformer that way. So in that case, they might put a battery at the substation and make sure that like any excess power that's being produced gets, put into the battery so that there isn't any, current going up the transformer. And so there's some of those things that they have to worry about. But yeah, I mean, the big mindset shift that we're going through now is that people are buying stuff that are actually useful to managing the grid, right? And that was not something that they ever thought about, right? But today, when you buy a new electric water heater, it often has an app that comes on your phone that allows you to determine when it, heats up the water, right? And the same thing's true with electric vehicle chargers, right? They have an app usually that says, please, charge the vehicle when it's best for the utility, or charge it when it's lowest cost for my tariff, or whatever it is, right?
Heat pumps are now starting to be that way too, dispatchable.
So that whole like cultural concept is difficult for both sides, right? So like on the one side, the utility is not used to asking for help. And then, right? Unless there's like an emergency, right? And so yeah. So I mean, I think they need some training on how to be a better parent. And then I think on the other side, customers are not used to being asked to offer, to be flexible, right? And as you were suggesting before, they don't really want to be inconvenienced from that. And so, I mean, today I don't think there is much inconvenience. You don't really care after you take a shower when the hot water is hot again. And so you're in this interesting spot right now where, because everything's connected, you have this ability to do this. It helps the utility. And so now I think folks are starting to say, well, if I give you a 20% off your bill, will you connect up to 5 devices into this sort of load flexibility, regime, right? So Duke Energy is rolling something out like that. And Arizona Public Service has been doing it for several years, and others. And so I do think we're heading in that direction. And there's a lot of people who are like, it's not that much of an inconvenience. I'll take 20% off my bill, any day. So I think we are headed into that place, but we got there from the other way around, right? We got there from the utilities wanting to keep things the way that they are and build central generation through transmission and distribution, and really fighting the grid edge stuff, to a place where the grid edge stuff is saving their bacon, right? I mean, they're getting calls from governors who are saying, why did you just quote this new manufacturing facility a 4-year timeline to get interconnected? I spent so much effort getting them to choose our state. You're supposed to do one thing. You have one job. Just connect them already, right?
And do it before I have to go for re-election.
Totally, right? So a lot of the utilities are now like looking at, this distributed capacity procurement that, Spark Fund has announced with XL Minnesota, right? And not because they love distributed generation, but just because they're like, well, we got to get, coach walls off our back and, figure out a way to interconnect these loads faster, or else, people are just going to get mad at us. Right. And so there's a lot of things changing about the way in which these norms were set up. And, it would have changed a lot sooner had we started with microgrids and then radiated out from there. But, we went the other way around.
Yeah, and we talked a little bit about being able to connect various devices and have the utility send a signal, reduce some load. So there's all this stuff that we can do with virtual power plants. And like you said, it's saving their bacon. So do you anticipate that we're going to see more adoption of those types of invisible signals managing loads for folks over time?
So I think there's a couple of answers to the question. I think one is, it's certainly speed to market really matters right now. And so, grid edge devices, distributed energy resources has, superior speed to market. It's a lot faster than building a new natural gas facility or whatever it is. The other thing that's really helping it is the modularity of it, right? So if you need a 5 megawatt solution on a distribution system, you can get a 5 megawatt solution on distributed energy resources. But, like the minimum size of a central generation facility that's cost effective might be like 250 megawatts or 100 megawatts, right? Like, yes, you can get a 450 kilowatt reciprocating engine, but those are generally not cost effective to run on a regular basis, right? And so, it's harder to see those, and people don't generally want them in their neighborhood. And so the modularity is interesting too, right? Is you might need 100 megawatts or 250 megawatts of support. You might need it 10 megawatts at a time in various places, and so that speed to market and then the bite sizes, I think, is also in favor of distributed generation.
How do you think our culture around the use of energy would be different if we had started with today's technologies and like we were talking about, like microgrids that just kind of built out and connected to each other? Culturally, would we say, oh, I'm going to get an EV and I'll just get an EV charge and I'll plug into the grid? Or would we be thinking, I'm going to get an EV, which means I also need to like increase my storage, and I'm thinking about how I use my own energy first, and then the grid is just sort of a backup supplement? Or would we be going to the grid first?
Yeah, no, it's a really great question, right? Because obviously, if we started with superior solar plus storage and you got the cost down, et cetera, like, my sense is it right now, like in Australia or Germany, where, a very efficient installation of solar and battery storage, you probably can generate power almost fully off grid for, 20 to 25 cents a kilowatt hour, right? With 4 to 8 hours of battery storage, right? Which is not enough all year round, but it's enough most days. And then, and then you start to say, oh, I've worked closely with my neighbor, then that reduces his cost of system and my cost of the system, right? And then the rest of the neighborhood, et cetera. So my sense is if we had started that way, people would be a lot more thoughtful about how their use of electricity was affecting, their neighbor. And you see that now, right? When you look at like Energicity and some of these other companies who are doing microgrids in Ghana, right? There's only so many kilowatt hours that come out of that system, right? And so people are starting to think about it and going like, well, is my use of this, the best and highest use, or is it better for that, flour mill down the road to use it to, produce more jobs locally? And then obviously they can increase the size of the system. But you would think that there'd be a lot more thoughtfulness around how does electricity work? Where does it come from, right? Like what are the impacts, right? I mean, today I'd say the vast majority of people are just like, wait, what is this like light switch even connected to? I have no idea, but it works.
Well, and I kind of feel like the utilities have kind of trained us to think that way. To just don't worry about it. We got it handled. Just flip on your light switch. Just use your power and pay us for it. And so people just aren't accustomed. And I don't know that everybody's going to go that route and want to be accustomed to thinking about their energy use in such a granular way. It kind of reminds me of like recycling. And some people are just like, "Ah, it's too hard. I don't know. It doesn't work anyway. It's just like not worth my time. I got bigger problems, right?"
Well, if you want to be a prepper, I mean, you got to know this stuff, right?
You do.
You want to be ready for the end of days. I mean, you need to figure out like a water cistern and like, like figuring out how you're going to heat stuff and cool stuff. And so I mean, I feel like there's some real practical use cases here to being smart on your electricity.
I agree. I mean, living in this RV has really opened my eyes a lot to understanding how all these different systems work, and having to play games with what power we're using if we're on 30 amp power versus 50 amp power, and it's fixing things that break. So it's been really good education. But I know that lifestyle is not for everybody, and it can be overwhelming for folks to think about it.
Totally. But some basic stuff, like in my opinion, like makes sense. Like for instance, if you have a solar system and an inverter and a battery, right? You produce solar power. Some systems are so badly designed that you then turn it into AC power and then turn it into DC power again and stick it in your battery, right? Then you draw it out of your battery, you turn it back into AC power, and then you put it into your outlet, and then your computer turns it back into DC power to power your computer, right? And so at some point you're like, what are we doing? We're just creating heat. All day we're just creating heat through all these conversions, right? And so like that's why I think one day we really should have DC wired houses. I think all houses should just be DC wired. Everything should be DC, right? And then when the AC power comes to your house, you just have a rectifier bridge there and you turn it into DC power before it comes in your house, right? And so like it feels to me like that is the right way to do things in the future, just because so much of everything we do is DC powered. The only stuff that's AC powered are things that have compressors or motors on it. Pretty much everything else is DC powered. And so like I do think we're in this weird place right now where everyone's used to AC power, but so much of our load now is DC power that, we're just wasting a ton of electricity just converting things from DC to AC back to DC.
Half of this RV is wired for DC power. So when you're on the batteries, you can only use the outlets on one side of the RV.
I love it. I love it.
We were talking about interconnections and generation at a large level or a smaller level. And it got me thinking about how at every conference I've been to this year, it's been all about data centers and AI and this increased demand for energy. And how are the data centers going to get their interconnections? And are they going to get to jump the queue, or should they just provide their plan from the beginning to generate their own power and not depend on the utility? And I would love to hear your thoughts on this, because this is one of those moments in society where we are going to build out a lot of new load, and we do have the opportunity to use this new technology in a different way should we choose to, but we still might end up making the same choice that we would make with our existing technology. So I'm really interested to hear your thoughts here.
Look, I think Morgan Stanley just put out a report that said that there's about 174 gigawatts of real fact-checked load growth that they believe is definitely coming online between now and 2030. And the amount of load growth that you could absorb without any real changes to the grid at all is about 15 gigawatts. So the question becomes, how do you add 174 gigawatts when 15 gigawatts is what you have available? Like, some of it's obviously going to be upgrading the grid and doing the things that you need to do to unlock things, right? Grid enhancing technologies, et cetera, et cetera. But some of it is this, Flex Connect approach where you say, all right, why don't you guys just all join, right? And because most of the year, about a third to a half of all of our generating capacity is underutilized. Right. So it's not like we don't have a capacity to add 174 gigawatts of load to the grid. We do. It's just that 50, 100, 150 hours a year, depending on where you are, the grid starts getting constrained, right? And so then the question becomes, what do you want to do during those 50, 100, 150 hours a year? Do you want to just, shut down and give people a holiday for those, weeks? Or do you want to put a bunch of batteries right next to your data center or whatever it is and say, you know what, screw you. Like, we're making so much money off this thing, we're going to run right through, right? And we're going to put in a bunch of batteries and do it that way, right? Fine, right? And so, like, part of where we're headed is that we need to stop saying that it's the entire system's responsibility to interconnect loads and to pay for 100% of the cost of doing that, right? So some of that cost has to be borne by the person who wants to interconnect to the load. They have to be a good neighbor, right? So now the question becomes, if you do that, what's the impact on the rest of the grid? It's actually quite extraordinary, right? So if the data center companies all put 8-hour battery storage units at all of their facilities, then those batteries can be used all year round, not just the 50 or 100 hours a year where they're challenged, right? They can use them the rest of the year too. Well, that makes everything more efficient for everybody else who's on the grid. And now suddenly electricity rates might actually go down, right? And that's pretty amazing, right? So my sense is that part of, this thought experiment that you're taking us down is one that starts from local and then expands to national. We started at, regional or national and went down to local. I think, the way out of this conundrum that we're in now is to think about what it feels like to start local and go regional or national, right? And that to me is a profound change in culture and thinking that we are all going through at the same time. Some people obviously are ready to go because they sell solutions for that. And others are saying, what? I connected 2 data centers 5 years ago and I didn't have to do any of this stuff, right? And in fact, you gave me an economic development rate at 4 cents a kilowatt hour because you're begging for all this property tax revenue locally, right? And so times they are changing, right? So things that people did 5 years ago, they can't do today. And so it'll be interesting to see. But my sense is that for most loads, including electric vehicle chargers or lots of other things, there are 50 to 100 to 150 hours a year that you can just say, like, we're just going to turn off because we don't want to pay for the extra batteries and we don't want to do all these other things, right? There's a lot of like manufacturing facilities who are fine to say, when the grid gets constrained, we're going to, do maintenance inside the facility and, shut down for that week or two, right? So I think there's a lot of people who are fine with this Flex Connect model. But for those folks who aren't fine, then build some shared infrastructure at your site to help accommodate your inclusion in the grid and, be a thoughtful neighbor.
I like what you're saying around bringing us to a place where we're thinking locally first and then broadening out from there. I kind of feel like you're seeing that in other aspects of society, you can have more of an influence and your vote matters more at a local level than it does at a state or national level. Your food is healthier if you purchase it from a local place. It's better for the planet if you're not buying things that are shipped from Mexico. This whole idea of starting local first is really interesting to me. I'm glad you brought it up because I kind of feel like the Industrial Revolution got us all these amazing things and brought us to all this wonderful places in modern society because it's like efficiency and scale and also resiliency. But then there's benefits to be had from the other way too. And I feel like we want to come to balance between these two things.
Well, yeah. I mean, on top of that, right, we have an epidemic going on right now of loneliness, right? I mean, there are people who literally live next door to somebody and have never met them, never talked to them, never knocked on their door. And that person certainly doesn't believe they can come over to borrow a cup of sugar. And so, we're in this place right now where we need neighbors and friends and regional governance more than ever, right? We need people to engage locally for lots of reasons, right? One is just affordability, right? I mean, telling the utility company and others that like, we want you to pick the more affordable pathway, not the pathway that's most familiar to you. But the other piece of it is to recognize that in these more fragile and more volatile times, right? The way to get through it is to, lean on the folks who are going through it with you, right? And I think that is really important. I mean, we always buy stuff at the farmers market, and I've gotten to know all the folks who, are our regulars, and some of them are waking up at 4 a.m. and driving from southern Pennsylvania all the way down here to Bethesda, Maryland, and selling their wares, and it's an extraordinary thing to see, right?
Yeah, and I feel like if we did have this sort of hypothetical microgrid first kind of setup, it would be necessity for you to communicate with your neighbors and talk about how are we all going to use this shared resource. And what I've noticed living in some small towns in Alaska, you know, off and on, is that you can't afford to be rude to your neighbor up here because if things go wrong and you need help, you need to know that you can ask your neighbor for help. If the weather's really bad or if you need a part that you just can't get, right? Because it's going to take too long or too expensive to ship up here. So those constraints then encourage community. I heard a story in Haines, Alaska, like one restaurant stays open. We'll have like community dinner once a week. So they'll open for one dinner. Everybody comes, and the folks started noticing that one person hadn't been to community dinner for like 3 weeks in a row, and so they drove out to his place to check on him just to make sure he was okay. And that type of community you don't see elsewhere because there aren't these mechanisms that basically force you to commune with your neighbor.
You are so right. I mean, and in Alaska, obviously, I mean, this stuff matters because it can be life and death in some of those communities. But I mean, in the rest of the country, I think we can learn a lot from Alaska. Like, I just think we're in this interesting spot right now where there is a feeling on people's part that that all these modern luxuries that we take for granted are things that can allow us to live a great life just within our nuclear family, and then you don't really need anybody else, et cetera. Then turns out COVID occurs, and turns out that like all these other sort of things happen, and you do need people. I mean, like we live in a throwaway society where some of our appliances don't last the 15, 20 years they're supposed to last, right? It used to be that your Kenmore refrigerator lasted for 25 years and you could get spare parts. And today, like your ice maker breaks and you're like, damn it, $800? The hell is that? I don't need ice. And so, get those ice trays back out. Like I'm using ice trays, right? And, like, I just think like the number of people who know how to fix things, the number of people who know how to like take care of things, like all of that community knowledge is there, but like a lot of people don't know it's there. They don't know where to go.
On this topic of communication and collaboration, you talked about the transformer and how it's not really designed to go two ways. And so you might do a battery to absorb that power so that it doesn't damage the transformer. But what about V to G? Like this two-way communication of power between homes and the grid. I feel like that has been talked about so much that people almost assume that it's a thing, but it's not really a thing. But maybe it's a thing, or there's the capacity to do the thing, but the utility doesn't want you to do the thing. So you have the Ford Lightning has the capacity for V to G, but your utility might not allow you to do it.
I feel like they need to come out with another truck called the Thunder, and then we'll use that like song, like thunder and the lightning. So I think it's amazing. I think we're in a place where I don't think people are against anything anymore. I think they're just confused around what the deal is with each other, right? Like so for instance, like I have an electric vehicle, and my electric vehicle, I mean, I really don't drive it more than, I don't know, 30 miles a day, maybe. And so, if I had some sort of setting where I was like, let's leave it at a 60% state of charge and the utility can just control it, and they can dump power into my battery when it needs to dump power all the way up to whatever 85% state of charge. And it can pull power from there whenever it wants to down to 30% state of charge. If everyone allowed for that, you could imagine they could just balance the grid with people's electric vehicles all day, right? Like when you think about like the peak load in the state of California is around like 40,000 megawatts, right? So 40 million kilowatts. And, an average, EV probably could do V to grid at like 10 kilowatts. That's 4 million electric vehicles, which they already have in the state of California. So for 4 million vehicles, you could basically load level the entire grid in the state of California every minute of every day. Right. And so you're like, it's a fascinating thought experiment, right? Because you have this ability to do this stuff, right? And it doesn't really affect the longevity of the battery that much, right? I mean, these Tesla batteries last 750,000 miles or so. And so, you can maybe reduce it down to 650,000 miles instead by, doing more cycles. And so it really is not that big of a deal. But, what are the norms around it? How do people get compensated for being flexible and helpful and the legal stuff? And so the good thing is we got the NEMA standard completed earlier this year. And so now you have the ability to do vehicle to grid, and we know exactly how to do it, and we know, what the standard is for doing it. And so that is a breakthrough, right? So it used to be that people did everything their own way and it was all proprietary. It's not anymore. And so now most EV chargers that are sold next year will have this vehicle to grid capacity because they'll just include the NEMA standard into it. So I think we're on track to having vehicle to grid, and then the utilities then have to say, well, maybe this is a much cheaper way of actually managing the distribution grid than, putting in home batteries. Like instead of making you add a home battery, how about we just let you run your house off of your car, right? And so it does feel like that is coming really right around the corner. I feel like we'll be able to run our whole home off of our car. Probably, you already have the ability to do it this year, but my sense is it'll be commonplace by 2030, right? And so, like, that feels like a really big milestone.
Now, do you think that they would be willing to go the next step, which is we had all these microgrids, people are buying their own EVs, they're leveraging that load and that storage for their house when they need it. They're using solar and they've got extra power and their neighbor needs it. So they can sell a little bit to their neighbor. Like right now, as I understand in California, you are not allowed to sell power to your neighbor. It has to go through the utility.
Well, that's true in every state in the country. And so I don't think that's going to change. But I do think that having your neighbor and your house and every other house on your block orchestrate their energy consumption within the loads that are, easy to orchestrate, that don't have a lot of, sort of consequences in terms of like you noticing, I think is something that we're going to get to. And I think we will actually be flexing 20% of our entire grid, right, by 2030, right, which is what we wrote in the DOE liftoff report for virtual power plants. I think that is going to happen. And just because everything you buy now has an app that comes with it, so you have the ability to do it. So, and I think ultimately you're going to see utility companies just say, we're going to give you all 20% discounts if you sign up 5 devices.
Yeah, it has to be a steep enough discount for people to pay attention. Because if it's just 5%, it's like, is it worth my time? I don't know. It's too hard. But 20%, you're like, maybe I'll do it for that. The other thing, like if we had started local and then grown to a national grid, do you think we would still have these different types of utility organizational structures, like a monopoly? Or I think we'd have a lot of co-ops because that makes a lot of sense if you're starting local and
Oh, for sure you would have, but we have a lot of co-ops now. I think we have like, I don't know, what is it like? Almost 3,000 different types of utilities in the country now, and most of them are co-ops and municipal utilities.
yeah, but I think of like these monopolistic utilities, the publicly owned utilities, and how they think about their financial growth in terms of what can they create, what can they build and rate base and get 10% interest on automatically. And that's kind of like the way they think about how they make their money sometimes. And maybe this is a broad generalization. I'm willing to admit that that's a broad generalization.
we lost our way, right? And it's not just with the electric utilities. We lost our way with Boeing, right? Where there's been financial people leading Boeing instead of engineers. And we lost our way on utilities. I don't understand why you would allow anyone that doesn't have an engineering degree to run a utility. But I think we're in this weird spot right now where we've had 20 years of no load growth. And so, basically when that happened, they got rid of all the engineers who ran utility companies. They replaced them with legal experts and regulatory experts. And, the utility industry lost its way. But I would say that they're back now. They recognize that they have way too much stuff to invest in, and they need the support of their customers and the regulators and the governors, et cetera, to be able to take this next leg up. And that's why I think you're seeing them start to embrace all sorts of new designs and microgrids and other things, because they're realizing that their customers want them and they're 90% cheaper than what they were going to do. And, it's extraordinary to see, right? I mean, for a long time, for instance, we were upgrading people's service from 100 amps to 200 amps or 200 amps to 400 amps. And now we're realizing you can just put a smart panel into their home with a little battery associated with it, and you can basically leave them on 200 amps. That saves $15,000 for upgrading a pole transformer. I mean, PG&E alone, I think, needs to rate base $7.5 billion of pole transformers between now and 2030. They're like, oh, this would cost less than $2 billion if we did it this other way. Maybe we should do it this other way. So I think that's coming to the right place.
So we've talked a lot about different aspects of the future and 2030 being a frame. So if you were to sum it all up, based on everything that you know and all of your experience, what do you think our energy system is going to look like by 2030? Where are we headed? Are we going to get to that dream place, or are we going to get halfway there? Piecemeal?
I think we'll get all the way there. I think that when you think about the prize at the end of the rainbow here, the prize is human flourishing, right? And the electric utilities have been in the business of human flourishing since we gave them a monopoly license 100 years ago, right? And so this is fully aligned with what they want, right? We are going to figure out a way to unlock AI. We're going to figure out how to unlock self-driving cars. We're going to figure out how to unlock all of this extraordinary new technology that we've all invented that make people's lives just a little bit better. And I think the utilities want that for everybody. So now the question becomes, do they want to do it the old way, which is going to double everybody's rates from here? Or do you want to do it the new way, which will keep rates under control for the next, 15, 16 years, right? Because we're going to double electricity sales by 2040, right? Double electricity sales by 2040, right? So my sense is the only way you get there is by doing stuff that's a lot more efficient and a lot cheaper. And that's going to mean all the things we just discussed. And it's going to be hard, culture change is hard. But I do think that, there's just no other way to prevent utility rates from doubling. And I think people recognize that, and they don't want utility rates to double.
And utilities don't want to lose their license to operate because they're allowing just the price to go up and up and up and up. Even if they do that, it's going to create such a pain point for people that they're going to seek out alternatives to reduce that pain and remove themselves, from the necessity of depending on the grid.
That's right. So I just think that we lost our way for, 20 some years, and that's fine, right? Things happen. But now people have a chance to redeem themselves and get back on track. And I think they'll take that chance, and I'm here for it, right? I don't see, sort of villains and heroes. I don't see hatred. I see, collaboration potential everywhere I see. And I think that, for a long time, there was hostility between the grid edge and distributed resource providers and the utilities. I think that hostility has largely melted away just because utilities are just hair on fire and sort of saying we need every great idea we could possibly find just because we can't meet this moment without all those great ideas. And we've got over 1 million extraordinarily well-trained people in our industry who are happy to help their neighbors, They're, folks who live in your local town, and they, I think want to figure out how to make electricity and all this stuff affordable for everybody. And so I think everyone's rowing in the same direction again.
Earthlings. What I'm hearing from Jigar is that energy isn't just about electricity, it's about supporting a society to prosper. It reminds me of another mentor I have, Neil Dykman, who we've got 2 episodes from him in the archives. Scroll back to the 2023 for those. And he says at one point, energy is life, the rest is just details. And it's really true that energy facilitates life. And what is life but um, who we trust, how we live together, what kind of future we're willing to build, and energy and power generation really supports that at a fundamental level. And it's reassuring to hear Jigger say that utilities maybe were once slow and cautious, but they're waking up to new ways of doing business, not just because it's good for the climate, but it's good economics, it's good policy, it's even maybe good neighborliness. And as we face this historic load growth from AI and EVs and data centers, the message is clear. We can't meet this moment with 20th century tools or 20th century thinking. We need innovation that is both technical and cultural. Because in the end, building resistant, affordable, and equitable energy future isn't just a matter of engineering. It's a matter of imagination on this beautiful blue-green space flower that we call home. Primary financial and production support for Earthlings 2.0 comes from Technica Communications, an award-winning PR firm amplifying breakthrough technologies of the future. Additional supporters include Greenlane, who is working to build a nationwide network of commercial EV charging infrastructure, Tygo Energy, a solar energy and software solutions provider focusing on commercial, industrial, and residential solar installations, Ampion, who is expanding renewable energy access for communities and Fortune 500 companies everywhere through community solar. 24/7 Solar, a next-generation concentrated solar power solution that's modular and can capture the sun's energy at a higher temperature than conventional CSP and store it in simple ceramic pellets. And the U.S. Biochar Initiative, who is increasing production and use of biochar in North America by developing markets, increasing awareness, and building community. And of course, our heartfelt gratitude goes out to you, our listeners, for your curiosity and dedication and showing up with us every week. Thank you so much. We do this for you. If you have a topic you'd like us to cover, or if you want to participate in our Pay It Forward guest model, please contact me at lisaan@earthlingspodcast.com. And you can search our entire archive on any podcast app as well as YouTube. And you can also go to earthlingspodcast.com and search our website there. Until next time, keep exploring and caring for this beautiful blue-green space flower that we call home.